All right, so this is chapter 9 review on page 611. And we're going to review lessons 1 and 2 first. But I have picked out some problems to work. I didn't pick out one, but might be helpful. All right, so the sine squared t plus the tan squared t plus 2 tan t minus 4 plus the sine squared t all over 3 tan squared t minus 3 tan t. So we're just going to simplify this in its most simplified form. All right, so anything that maybe we can simplify in the numerator? Yes.
For tan of x, or sorry, for tan of t, we can substitute like x, and then once you've done that, we can factor it and find the answer or just basically simplify that, so we're able to.
I see something else. Yes.
You either move the 2 to the front or move to the.
Okay, I see something even simpler. Corinne,
Sine squared plus cosine squared is equal to 1.
this plus this equals 1.
Okay, where is that?
It's Pythagorean. Sine squared plus cosine. All right, that's what I would do. Tan squared t plus 2 tan t minus 4 plus 1. What can you do in the denominator? I can factor. What can I factor out? I can factor out a 3 tan t. I'm left with tan t minus 1.
Okay.
Yes.
You would not. You couldn't if they were both tan of t though. It would just be 0 because 3 tan t minus 3 tan t is 0. Right.
Right. Correct.
But you can't do it.
But then that would be
because it's
undefined.
squared. Yeah, but you can't
Correct.
do it because it's squared.
Yeah. Correct. All right, so let's combine the 4 and the 1 in the numerator. All right, Nathaniel, what can we do in the numerator? Everything's in the tan. I like that, right? I'm not going to any other.
Couldn't you do like the quadratic formula or something?
Well, it's not equal to anything.
Oh yeah.
So I'm not using quadratic formula because it's not equal.
So you got a factor.
Okay. What is the numerator factored? What is it factored? Factors of -3, such that we add them in the +2.
-3. I mean, -3. Positive 3.
+3, -1. Exactly. Okay. Now what would you do? Cancel out our like terms. So now we have tan t plus 3 over 3 tan t. Can I simplify that anymore? Well, now I have numbers added in the numerator over one common denominator. So I can break this up to the tan of t over 3 tan of t plus 3 over 3 tan of t. Right? When you have values added in the numerator over one common denominator, you can break them up into two separate fractions. Why would I do that?
So you can simplify.
That's 1/3 plus What's 1 over the tan?
Cotan.
1 over the tan is the cotan. That's as simplified as I can get it. Here's what I wanted you to see. I wanted you to see, guys, that sometimes the answer is just 1. Sine squared plus cosine squared is just 1. And can you pull that out in an equation? All right.
We should edit
Got it? Everybody got that? All right, number 5. No, yes, number 5. Goodness. All right, so number 5's instructions determine, we're not determined graphically, we're determined algebraically if this is an identity. All right. I would say let's start working on the left-hand side. All right, what do you think we can do on the left-hand side? Yeah. Factor it. So what are the factors?
Sine squared t minus cosine squared t, sine squared t plus cosine squared t.
Correct. All right, so now, yes.
The sine squared t plus cosine squared t is equal to 1, so then it's just
This equals 1.
squared t minus
Okay, yes.
Do we wanna, we could replace negative cosine squared t with, well, I mean, we could.
Yes, Therese. Yes, we do.
So would it be negative, or would it be sine squared t minus 1?
What are we substituting in for cosine squared t?
Well, so 1 minus sine squared.
Correct. So distributing our negative. Do we have like terms?
Yes.
So we have 2 of the sine squared t minus 1. Does that equal? Does that make sense? Why at this point would I have wanted to substitute in cosine? Yes. Because I only have sine on the other side. So that's what was the driving force behind getting rid of the cosine. Make sense? Okay. Y'all better know number 7. I'm going to be so disappointed if you don't know number 7. So don't say anything, just look at it. I keep wanting to write X, so if I mix the T's and the X's up, just go with me. I'm really, using lots of brain power to write a T, and I shouldn't be using that much brain power to write a T. Okay. All right. Does everybody recognize this pattern? You should recognize this pattern. So what am I going to do, Mackenzie?
Wouldn't you multiply both sides by their, I guess, reciprocal? Which is
I would not do that. I'm only working on one side.
well, not. Well then, oh yeah, you would just multiply one side. Or I
By,
guess
okay,
By 1 plus cosine of t over 1 plus cosine of t.
correct. So I'm not doing anything to the right-hand side. You could have multiplied this side by 1 minus cosine t over 1 minus cosine t. That would have been fine. All right. I'm not distributing the numerator. The one that has the single term times the binomial, I'm not distributing. What's 1 plus cosine t times 1 minus cosine t?
1 minus cosine t squared.
Yes. That's sine squared.
You can cancel one out so that equals.
Cancel one of the signs out. And it does equal what is on the other side. That pattern holds true every time. All right, number 15. What side do you want to work on?
The secant left.
Left. Okay, what do you want to do?
1 over the cosine minus the cosine.
Yes, you want to write the secant as 1 over the cosine. All right. Now what do we want to do? What do you think?
Multiply c of 1 minus cosine squared x over cosine.
I think I want common denominator. So multiply this by cosine x over cosine x. Got it? So now it's a common denominator of cosine x, and it's 1 minus cosine squared x. Yes.
Would you simplify the right side too? So that,
I don't think I need to.
okay,
Yet.
then that equals sine squared.
Correct. Yes.
So sine over cosine equals tangent, so we can pull out the tangent and sine times tangent.
Okay, is that the same thing as the sine of x times the sine of x over cosine x? Yes, it is. So it's a sine x tan x, and it does equal sine x tan x. All right, so 17. We have to match to A through E. Well, it won't be too terribly hard, I don't think. All right, so 17. We have the square root of 1 minus cosine squared x over 1 minus sine squared x. That's the same thing as the square root of 1 minus cosine squared x over the square root of 1 minus sine squared x. Yes?
Isn't that the same thing as sine squared x or cosine squared x?
Yes, yes. Sine squared x over cosine squared x.
And is that the same thing as square root of tan squared x, or no?
Okay, okay. Notice it's in absolute bars.
Wait, why would
Yes.
you put it in absolute?
Why-
Where did the negative go? Like,
Okay, what's 1 minus cosine x? Sine
oh,
squared x. And 1 minus sine squared x. Because when we take the square root of something, it's both plus and minus. That's why we have the absolute bars. Because regardless of what the tan is, when you multiply it by itself, it's always going to be positive.
Will we have to do that on the test?
No, you don't have to. You don't even have to do plus and minus. You can just leave it plus. All right, number 19.
Not like B, C, D, all the.
Well, it only matches A. It only matches one of them. So A. All right. Number 19. That's times. Okay, I would work on the left-hand side. What does this look like? What does that first term look like? Sum. Cosine of the sum of angles.
Should you change it to the product? Or would that just be more?
Product,
Like, would you use the sum and difference formula?
I would use sum and difference.
That's what I meant, change it to difference.
Yes, 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 yes. I would use the sum. And remember who's boss?
Cosine.
Cosine. So this first term is the cosine x, cosine y. Plus is minus. Sine x, sine y. That's the first one. Then we have cosine x, cosine y, plus sine x, sine y. Yep.
Why wouldn't you use product to sum formula? Or could you even?
Because I only have x's and y's. I don't really have a value for u and a value for v. And it just looks like that's where I needed to go. Because it looked like the sum and difference. And as opposed to the sum. It wasn't like cosine x plus cosine y. Okay, they're conjugate terms. So let's multiply them. What do we end up with?
Cosine x, cosine y, like square both of them, minus sine
So
x.
cosine squared x cosine squared y minus sine squared x sine squared y. What do we want to keep? We want to keep this, and we want to keep this. Right? So what could we substitute in for those? 1 minus, wait, is that x? Let me make sure I wrote that down right. It's y. Okay, I don't want to keep that one. This is y. So I want to keep the first one and the last one. So cosine squared x, and this is going to be 1 minus the sine squared y. You agree?
Wait, what?
For cosine y, 1 minus sine squared y. Minus, for this one, that's the one we want to get rid of. It's what? 1 minus cosine squared x times the sine squared y. Yes?
Is that one on a different sheet that we had, or were you just supposed to move this? Like just change.
Okay, so here's what it looks like originally.
The one minus the cosine.
Sine squared x plus cosine squared x is 1. If I'm solving for the sine squared x, I'm subtracting the cosine. So sine squared x is 1 minus the cosine squared x. So it's that Pythagorean identity.
Oh, okay.
Got it?
Yes.
All right, now let's distribute. Say we end up with cosine squared x minus cosine squared x sine squared y minus, no, I'm distributing. That's going to be minus sine squared y. See, I'm distributing. Minus sine squared y. Now this is going to be a negative times a negative, so this one's going to be positive. Cosine squared x sine squared y. They cancel out. So we end up with cosine squared x minus sine squared y. All right, makes sense so far. All right, number 23. iPad. 23. All right, the sine of x is negative 12/13. What quadrant am I in?
Quadrant third.
I'm in the third, so I'm drawing my triangle. Here's my x, so it's opposite over hypotenuse, and this is negative 5 because it's a 5, 12, 13. And it says the secant of y but let's write the cosine of y. What's the cosine of y? It gives us the secant of y.
Should be 1/13.
It's what?
12/13.
Yeah, 12 over 13, it's just the reciprocal. And it is in quadrant 4. So here's y. This is 12 over 13, so that's negative 5. I keep going up to the one above it. Yes,
The diagonals will never be negative, right?
correct. Correct. It's
Why
always,
is that?
because when I square a negative number, it becomes positive. This is
Oh,
negative
yeah,
5
yeah.
squared plus negative 12 squared. It's that you always end up with positive numbers. Your hypotenuse will always be positive. All right, so now we want the cosine of x plus y. What am I using? Yes.
So cosine, would you, cosine x is at negative 5/13. So would
Well,
you,
what am I using for my trig identities? Sum. Cosine's the boss. Plus is minus. That's the cosine x, cosine y, minus sine x, sine y. See, y'all have that memorized. All right, the cosine x, third quadrant, it's negative. It's negative 5/13. Well, the cosine y is 12/13. Minus sine x, it is negative. So that's negative 12/13. Sine y is also going to be negative. It's negative 5/13. So we have negative 60. What's 13 times 13? Is that 169?
Yeah,
And it's
it-
going to
it
be
is.
minus another 60 over 169, which is negative 120 over 169. I don't know if that can be
And
simplified.
that's the answer.
That is the answer. I don't think it can be simplified. 4 doesn't go, 3 doesn't go into it. 2 obviously doesn't. All right, so I had to look at the quadrant. Draw your triangles. Do y'all remember what the tan is? All right. Let's do the tan of x plus y. Plus is plus minus. Plus is plus minus. It's 1 minus the product. So this is tan, sorry for my voice. And this is tan x, tan y.
What are we?
Well, I made this one up. We're doing the same problem, but doing tan x plus y. Same problem. All right, so the tan of x is going to be positive. It's TOA, opposite over adjacent. So that's 12/5 plus the tan of y is going to be negative.
negative 5/12.
Minus 5/12 over 1 minus 12/5 times negative 5/12. Oh my goodness. This was not a good problem to do this with. Oh, not too bad, actually. I was thinking it went undefined. Okay, so let's multiply this one by 5/5 and this one by 12/12 so that we have 144/60 minus 25/60 over. That's 1 plus 1, which is 2. What's 144 minus 25? 119 over 60 over 2. 1/2 over 1/2 to eliminate that denominator. 119 over 120. Got it? It's just algebra, yes.
So what is that equal? That thing right there?
It equals the tan of x plus y. Makes sense? And this equals 120 over 169 cosine of x plus y. Make sense? All right, look at number 26. Find an exact value. What are you thinking of when you hear the word exact value, Jaden?
Well, I was gonna say, you go to the unit circle and you do.
That's right. When you hear the words exact value, you better be using numbers that are on the unit circle. All right, but is 5 pi over 12 on the unit circle?
No.
It's not. So I either have to add or subtract. All right, so what are we gonna do, Jaden?
You would do 2 pi over 12 plus 3 pi over 12.
Yes, 2 pi over 12 plus 3 pi over 12. Yes.
In what scenario would you do 5 pi over 6 over 2? Like the minus. Like the.
So if they were trying to find the half angle.
We're not trying to find the half angle. We're trying to find, that's right. Anytime you're doing the square root, that's the half angle. All right.
It'll say find the half.
It would have said
Okay.
5 pi over 12 over 2, or it would have said that. All right. All right. Sine pi over 6 plus pi over 4. Sine is what? Sine cosine, cosine sine. Sine cosine, cosine sine. Got it? So, tell me what is it?
Sine pi over 6.
Sine pi over 6 times
Sine pi over 4.
cosine pi over 4.
Plus.
Plus is plus.
And then it'd be the cosine pi over 6 times the sine pi over 4.
We already know the cosine and the sine of pi over 4. It's the same number. What is it?
Square root of 2.
Square root of 2 over 2. We're all in the first quadrant, so everything's positive. Sine counts up or down? Up. Pi over 6 is that first one after 0. So it's 0, it's 1/2. So the cosine has to be the other one. Square root of 3 over 2. So that's the square root of 4 over 4 plus square root of 6.
Square root of 2 over 4.
Yeah, square root of
Oh,
2.
yeah, that's exactly what I meant. Thank you. Square root of 2. You can't simplify that.
That would just be your answer.
Yes. I bet your textbook did square root of 2 times 1 plus square root of 3 over 4, but that's
You
doesn't
accept the
simplify
other
it. That doesn't simplify it anymore. I don't know what your book did.
So-
Actually, they didn't. They just did square root of 2 plus square root of 6 over 4.
They can accept any of those.
Yes. I really don't like that one. I just don't. Okay, that is